Welcome to the Pavement Construction Project Report. I'm Kyomama, Senior Engineer, Roads and Structures Assets. And the bypass will be constructed over a river. Part of the project will cross a floodplain with clay soil. The bypass will be used by heavy vehicles, and we need to produce reports on pavement layers, material spec, construction method, plants and equipments. This is an overview of the bypass. You can see from the south to north the bypass passes, and towards the north there's a floodplain and also a black river which will be crossed using a culvert. This design traffic and CBR, these were calculated from the field data. Based on these two design traffic and CBR, we can calculate the thickness. This thickness is calculated from the Ostro's guides. You can see CBR on the right side and design traffic on the bottom, and based on the different CBR there's a gradient line. So for CBR 3 and design traffic 8 10 to the power 6, we can see that it meets here, somewhere here, and we can see it's roughly equal to 625. So that's how we calculated all these thickness layers. You can see towards the intersection there's a lower traffic, so we have to design based on the worst case scenario. So we'll be choosing 625 and also 310 for the whole design. This is the segregation of different layers: base, sub-base, soft soil. Soft soil has been attributed because of the poor CBR. We may use a capping layer or do stabilization to improve this, and other than that, base is 150 and sub-base is a deduction from 625, the remaining numbers. You can see capping layer. The capping layer is kind of like a foundation which supports the overlying pavement layers, but it needs to be impervious so that when the expensive clay is at the bottom, if it is impervious, it will have a great support to the overlying layers. We can also improve using the stabilization. We need to do a trial for initial 100 to 200 meter section. We'll be using pneumatic rollers. Start with low pressure, which will create a larger contact area and spread the wheel load. But as the material gains strength, we'll increase the tire pressure, which will reduce the contact area, and it will apply a higher compactive force. Before work, please check whether the soil has soluble sulfates or organic soil. Because it's for the drainage, it's a rural area, we'll rely on surface drainage, which is shoulder widening, adequate crossfall or one-way crossfall, or maybe random subsoil drainage, which is optional. The material can come from the nearby river if there's any source, and quarry near or far. When it's from the river, we can use bulldozer, grade, loader, pug mill, etc. to extract the material. And when it's quarry, we have to beware, look for the maneuvering of the truck, the parking and positioning, and so that the trucks doesn't obstruct any other trucks entering the construction area. Some tests we need to do on the materials: particle size distribution, plasticity and permeability requirements, soundness and strength requirements. All are from Transport New South Wales standard test. During the placing of the sub-base and base material, we have to be wary about how the material is being delivered and the compaction of different layer thickness. And if there's an inbound material, we have to be aware about the limits imposed by the characteristics of the binders, such as chemical and temperature changes. For example, cement stabilized crushed rock has a set period, while bitumen bound material have a temperature range. We have to consider this during placing. And for grade controlling, We'll use a autograde or self-propelled spreader. That irregularities can be easily identified and allowing the can to reflect on the pavement surface. Culvert will be used to cross the river. We have to look for the width of the river and including any vegetation until stable grounds are reached. Culvert and components needs to be constructed outside as much as possible to reduce impacts on the river and environment. And to protect against scour, we need a riprap or vegetation in the upstream, and for downstream, the scour protection should extend twice the channel width or 20 meters, whichever is less. The box culvert construction planning, the road loads will be based on SM1600 loads. Approach road and road pavement over culvert can be constructed once culvert is fully established. Pavement layers on culvert is constructed without base, subbase, or subgrade. So basically it's a asphalt layer placed in layers of 100 to 150 millimeter thick. If there's any whip holes, the culvert, then crushed rock or gravels with geotextures are placed behind the wall. And of course, we have to maintain erosion and sediment control throughout the project. This is the final design of the bypass. You can see the spray seal has been used for the bypass, and when crossing culvert, we'll use asphalt and base, subbase, and soft soil. So the material spray seal S45R is a chrome rubber based spray seal, and it's selected based on Oxford guides because of its superior stress performance and fatigue performance. Final design of southern bypass, we can see it's all the same. We'll be using the same material for base and sub base, which is class 1 DGB20 and DGS40. Northern intersection, this is a bit interesting because when it's intersection, we're gonna use 200 meter before we reach the intersection on some asphalt. So accordingly, we have to reduce the thickness of the subbase because that's a cheaper material. And so we'll be reducing the thickness 375 to 325 to make the transition smooth and so that there's no sudden jerking or uplifting of the vehicle. Similarly, on the southern side, we'll be using asphalt 200 meter before the intersection. So the subbase is adjusted accordingly from 160 millimeter to 110 millimeter. During the construction, we have to be aware about key safety control measures, which are work health and safety management system, the traffic management, movement of heavy machineries, excavation and trenching, working at heights, hazardous substance management, emergency preparedness and first aid, site security and housekeeping. Key environmental control measures that we need to be looking after: construction environment management plan, erosion and sediment control, water quality management, dust and air quality management, noise and vibration management, waste management and resource recovery. You may remember it's subject, the area is subject to protected wildlife and some remnant vegetation, so we need to have a clear control over flora and fauna protection, heritage protection, and community engagement. Thank you everyone for your attending today's presentation. If you have any questions, please let me know.